You know that if you use distant supervision, suddenly you create noisy labels. And this article tries to solve this problem as much as possible. So we have relation extraction, we have two entities, entity 1, entity 2, and it automatically, naturally attends to some tokens. So remember the produce noisy label that we hated in the last lecture. So in order to deal with these problems, there are lots of noise reduction articles. So the idea of this paper is that it iteratively learns an interpretable model and utilizes it to select trustable instances. So we first introduce attention regularization to force the model to pay attention to patterns which explain the relation labels. And you may say, how do you know these patterns? Well, we know we can create a small label dataset manually, and after that apply your relation classification on that. Then if you look at the attention weights, you will see that these are true things that we have confidence of, and there is a high confidence on that, and we can use that for our patterns, those patterns that I mentioned here. For example, if you just use this knowledge base, you create some, sometimes it works like this, sometimes it doesn't work. And it attends to, most of the time, on these two entities. But you see, this is very small, but we want to make it higher. So how can we create this inductive bias? As I said, we use attention regularization because we have a manual dataset, we have a manual expensive dataset, but it is small. We use the confidence of that in order to force that, and we do it by KL divergence between what is desired and what is predicted. And after all, we also can correct our confidence, increase it. And so in different epochs, it learns how to attend to things that has never happened before, because most of the time it attends to the entities and not the other words in between or before that or after the second entity. So the idea is that attention regularization is applied to guide the training of the model, forcing it to pay attention to given pattern words. Then we select instances by checking whether the model can give a clear explanation for the relation label generated by distant supervision. So first of all, we use this attention-based BioLSTM, this part of that, until this. Here is everything normal as we do for relation classification. And then we use KL divergence between what is true and what is predicted, and this is just the loss. But we add it to the loss of classification as well, so that the augmented loss is the true loss. And for the desired pattern, we just simply use this. E1 is usual, entity 1, entity 2, and this is something new. This is something that has been learned from a very expensive supervised and manual text for relation classification. And these patterns, these M are created and learned before in a different algorithm. So we use that for our desired distribution of these attentions. And for instance selection, we again use that KL divergence, because if the KL divergence is high, it means it's very bad, that your confidence score would be very low. And we use bootstrapping learning procedure because we need more precise patterns in order to guide the model to attend to important evidence for relation classification. So this is the algorithm that we get the confidence score by that formula that I said, and we just train the classifier. But finally, we redistribute our dataset and by a new one. And again, this new one comes here and this loop happens. So But the problem is relation extraction is how to build a relation pattern extractor. As I said, we assume that we have access to some manual labeled data, which is of course expensive, and we have learned that we know the weights of the attention. And so we should do better in future, because as you know, the F1 score is low, and so we can do better than this. So this is an example that shows the heat map of the attention cases, and these are the pattern set cases.